Hey everyone, and welcome. I am absolutely thrilled to have you here for today's explainer. We are diving headfirst into literally one of the most fascinating, rapidly evolving spaces in tech right now, AI agents. You hear the buzzword everywhere, right? But today, we're going to demystify the magic. We're popping the hood to break down exactly what makes an AI agent tick, and spoiler alert, it's not sorcery, it is just really smart software. So grab a coffee, settle in, because we are going to build a solid, structured understanding of this incredible tech. So are AI agents really just beefed up chatbots? It's a provocative question. Because think about it. For the last couple of years, our entire paradigm of interacting with AI has been trapped inside text boxes. We type a question, it types back an answer. But to truly grasp the future of software, we've got to shift our mindset away from just conversational AI and start thinking in terms of structured, multi-step software processes.
Okay, let's dive into this using a company analogy. Think of a chatbot as a highly knowledgeable receptionist. You walk up, ask a question, and it gives you a great answer based on what it knows. But it never actually leaves the front desk. An agent, on the other hand, is like your project manager. When you hand an agent a task, it actively plans, it picks up specific tools, and it maintains a state of the project over time to actually get the work done. It doesn't just talk, it acts. Here's our roadmap for today. We're going to hit 6 specific building blocks, moving from a chatbot to a system, understanding tools and memory, specializing agents, setting up guardrails, navigating governance and privacy, and finally, learning agentic thinking. All right, kicking things off with section 1. From chatbot to system, we're looking at agent architecture as a completely new form of software. And this brilliantly illustrates the foundational mindset shift I was talking about. An agent is not some massive magical brain, it's a tightly controlled workflow. When an agent gets a goal, it doesn't just spit out the first thing that comes to mind. It processes that input, breaks the problem down into a deliberate plan, selects the exact right tool for the job, verifies the result it gets back, and only then does it decide, hey, am I ready to give a final response, or do I need to loop back and try again? Breaking it down into these distinct steps proves we are dealing with logical, manageable mechanics. Moving right along to section 2, tools, sandbox, and memory. This is all about giving our AI capabilities outside the model itself. Think about it like this. If the AI model is the brain, we absolutely have to give it hands to manipulate the world, and a memory to keep track of what the heck it's doing. In software terms, this memory is called state. State is simply the stored information about the current task, the history of what's been tried, intermediate results, and any pending decisions. Why is this absolutely crucial? Because an agent without state would be dangerously forgetful. Imagine a project manager who forgets the entire point of the project every single time they send an email. Not great, right? State allows the agent to pause, wait for a human to approve something, and then pick right back up exactly where it left off. Now, what's really interesting about this breakdown is how giving an agent different tools completely changes its risk profile. Let's contrast a few real-world examples. A research agent obviously needs a search tool, but the risk there is pulling in bad or biased sources. A support agent? Well, that needs access to your CRM to look up customer data. But boom, that instantly introduces massive privacy risks. And a coding agent needs a sandbox to run tests. But if that thing runs wild, the risk is actual system damage. The capabilities you give it have to perfectly match the constraints you put on it. Which brings us to section 3, specialized agents and handoffs, division of labor without losing control. As tasks grow in complexity, relying on one single do-it-all agent becomes literally impossible. It just gets overwhelmed with conflicting instructions. That's exactly where we use a handoff. This is where you transfer a specific branch of work to a specialized agent. So instead of writing one massive, chaotic prompt trying to force an AI to be a coder, a lawyer, and a customer service rep all at once, a main agent delegates. A triage agent might receive a customer ticket and immediately hand it off to a specialized billing agent, which operates under totally different rules and maybe even runs on a completely different AI model. The underlying mechanism making those handoffs work so smoothly is called routing. Routing is essentially the traffic cop. It's the intelligence that decides which specialized agent or which specific tool is responsible for a given piece of the puzzle. It makes sure the context of the task isn't lost in transit, filtering the information so the specialist gets exactly what it needs to do its job, without getting bogged down by irrelevant data. But here is an absolutely critical question for you to consider as you start designing these systems. In a massive multi-agent workflow, who is actually responsible for the final answer?
Does that specialized billing agent reply directly to the customer? Or does it report back to the main triage agent, who then synthesizes the final message? This concept of synthesis responsibility is a massive architectural choice that completely dictates how predictable your system is going to be.
Let's move to Section 4 and see how this builds into guardrails and human control. We need security in these multi-step workflows.
So once you have multiple agents picking up tools and routing tasks all over the place, you absolutely need to implement the breaks. Otherwise, you risk some catastrophic real-world side effects. We call these breaks guardrails. A guardrail is an automatic check or safety rule baked directly into the workflow itself. And I want to be super clear here. System security does not come from blindly trusting that the AI model is somehow smart or aligned. Real enterprise security comes from strict software architecture that ruthlessly validates what goes in and what goes out.
To actually build a safe system, we use escalating levels of control. Think of it as a defense in depth. First, input guardrails block bad prompts from ever even reaching the model. Output guardrails check the response before the user ever sees it. Tool guardrails restrict what functions the agent can physically trigger. Then we step up to paused runs, where the system literally stops and waits. And finally, the ultimate break, the human in the loop. Basically, any agent action that has a real-world side effect, like deleting a file, sending an email to a client, or making a purchase, absolutely requires explicit human sign-off. No exceptions. Next up, Section 5, Governance and Data Privacy. Figuring out which agents are allowed to do what. So the crucial point when deploying agents in a corporate environment is the principle of data minimization. You cannot just let data flow everywhere. Not all information should be fed into the AI model. We have to separate the context. The conversation history is what the language model actually sees and processes, but the run context, things like background state and intermediate tool data, that can stay securely siloed in the application code. And the application context, the user permissions and roles, that governs what's actually allowed. By keeping these separated, we protect sensitive data from ever unnecessarily entering the AI's processing window. Finally, Section 6, Learning Agentic Thinking. Let's talk about flowcharts and your professional competence. We've talked a whole lot about software and architecture today, but the single most important component in an agentic ecosystem is actually you, the human. We are moving into an era where agentic thinking is the new digital literacy. It is no longer just about writing a clever text prompt, it's about advanced process competence. You have to learn to meticulously design, break down, and orchestrate controlled AI workflows. Understanding exactly where to put a human in the loop, what specific tools to authorize, and how to verify intermediate steps, that is literally going to be your ultimate competitive advantage in the modern workplace.
To bring this entire explainer full circle, I want you to remember this one incredibly important quote from our source material. An agent is not a magical intelligence, but a controlled work process. If you anchor your expectations securely in the real mechanics of software architecture rather than Hollywood science fiction, you are going to be able to build and utilize systems that are incredibly powerful, highly reliable, and above all, safe.
And that wraps up our breakdown of AI agents. But I want to leave you with this final provocative question to chew on as you go back to your desk today. Take a hard look at your own daily workflows. Which tasks are you going to architect and hand over to agents in the future? And which core responsibilities are you fundamentally going to keep for yourself? Think about it. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you next time.